Okay, we're going to look at section 6.4, which is about the properties of parallelograms now. So a parallelogram is, by definition, a quadrilateral, which is a four-sided polygon with parallel opposite sides. And hence, that's how it gets its name, right? Okay, so the three things that I have examples of. The question is, are they really examples? Are those parallelograms? Because the first one is clearly a rhombus. When four sides are congruent, it's a rhombus. When the four angles are congruent, right angles, it's a rectangle. And when the sides and the angles are congruent, that's a square. So the question is, are these parallelograms? And the answer to that is yes. Okay, these are the special parallelograms. And we're going to learn more about them later this week. But I just wanted to introduce these. These are special parallelograms. But today, we're not going to focus on these special ones that have special properties. We're going to focus more on a general parallelogram. So we're going to focus on a parallelogram that looks like this, where you don't have congruent sides or congruent angles. All the angles aren't congruent, all the sides aren't congruent. If you have just a general parallelogram, meaning AB is parallel to DC, and also AD is parallel to BC. If you have just that, what properties can you find in a general parallelogram? Now, just a reminder, the definition says that parallel opposite sides. So these markings right here are part of the definition, opposite sides being parallel. So according to the definition, AB is parallel to DC, and also side AD is parallel to BC, just by definition. Now, beyond that, what measurement properties do we have of parallelograms? And that's what we're going to look at. So I'm going to pull up Desmos, and I'm going to go ahead and start doing some measuring. So I'm going to, let's say, measure the side length right here. So I'm going to measure its length, and it's 9.51 units. I'm going to measure that length. It's 4.54 units. I'm going to measure another side's length and the fourth side's length. All right, and what you may notice is that we have some sides that are congruent to each other. And you'll notice I've created a general parallelogram that can move into any parallelogram. Just by moving the vertices, I can change it into any parallelogram I want it to be. But what you should notice is that the opposite sides are congruent to each other. So that is the first property that we're going to write down. So the first property is that opposite sides are congruent. So you can draw a little sketch of that. Draw a little parallelogram next to the property. And so opposite sides are congruent. Not saying all four sides are congruent, as we saw in that measurement, just opposite sides are congruent. All right, let's go back to the picture. This time I'm going to go ahead and measure the angles. All right. Uh-oh. Made a mistake there. Let me try that again. There we go. Okay. So if I move, I did it again. 1, 2, 3. There we go. Okay. So if I move this parallelogram around, the angle measurements change as I move the parallelogram around, but you should see a pattern. And the pattern that you should see is that opposite angles are congruent to each other. So like this angle I don't know how to indicate what angle I'm talking about in this program, but opposite angles. These two are congruent to each other, and then these two near to each other are congruent to each other. So 78 and 78, 102 and 102. If I move it around, then I have 122, 122, and then 58 and 58. So opposite angles are congruent. So that is property number 2. Okay, so if you have a parallelogram, then opposite angles are going to be congruent to each other. All right, now besides having opposite angles, we also have what are called consecutive angles. So in this picture up here, A and D would be consecutive angles. Also, A and B would be consecutive angles. If they're not opposite angles, then they are consecutive or next to each other in a quadrilateral. Now, those properties you should already be familiar with. Let's see if we recall from several chapters ago. I know that AB is parallel to DC, and that means that AD can act as a transversal. So then angle A and angle D are consecutive angles, but they're also, if you recall, what we call same side interiors. We call these same side interior angles. And if you remember, same side interior angles are supplementary. So that means all of the consecutive angles are supplementary. So in this picture, you've got the 122 and the 58. Those two are supplementary. 58 and 122, again, are supplementary. And I can change this picture, and they're still going to be supplementary. 92, 88, those are supplementary. 92, 88, those are supplementary. 88, 92, those are supplementary. So it doesn't matter how I change this parallelogram, I'm going to have consecutive angles that are supplementary. One more example, 50 and 130, that's 180. So our third property of parallelograms would be that consecutive angles, so anything that is not opposite are consecutive angles. Consecutive angles are supplementary. So let's do a little sketch right here. Angle A, angle B, and angle C. So what we know is that angle A added to angle B would be 180. But we also know that angle A added to angle C is 180. All consecutive angles are supplementary. Okay, we'll start the next page on the next video.